All right, so now we're on to some hard equations. So this is how we obtain the correlation coefficient and the equation of the regression line. So the easiest way to find these two items is to use a graphing or statistical calculator. And that really is going to be the key. If we do that, we'll get our answers right away. We don't have to do anything, and that's going to be the best way to do it. And most of our calculators in class hopefully will be able to do that. Now, graphing calculators have statistical menus that enable you to enter the X and Y data for the variables, and then based on this information, you can instruct the calculator to display a scatter plot, the equation of the regression line, and the correlation coefficient. Now, we can also do all this by hand. And so that's what we're going to do. We're going to try this all by hand. So first, we have to compute the correlation coefficient. So computing that gives us this big nasty equation. So we need to find r is equal to n times the sum of x times y minus the sum of x times the sum of y divided by square root of n times the sum of x squared minus the sum of x, the quantity squared, times the square root of n times the sum of y squared minus the sum of y quantity squared. So n is the number of data points, however many xy things we have. So if we have 10 data points, n is going to be 10. Sum of x, we just add all the x's together. Sum of y, we add all the y's together. Sum of xy, that's going to take and multiply x times y and add all those together. Sum of x squared, so we're going to take all the x's, square them, then add them up. The y's, we're going to square all those and add them up. And then here we're going to take all the sum of the x's and square that quantity. And here we're going to take all the sum of the y's and then square that quantity. So there's a lot of stuff we need to do in that one. And then when we're doing these, it's sometimes best to kind of work in 5 columns. Our x column, our y column, our x times the y column, our x squared column, and our y squared column. And you can see that would get us the x, the y, the xy, the x squared, and the y squared. Now this one, we just have this number squared and that number squared. So we really don't need a column for that one. Oh, so once we find the sum of the numbers in each column, then we substitute those back in and we can get r. Now, once we've determined the two variables are related, then we can use the equation of the regression line below to determine the exact relationship. So this one is going to use, again, writing the equation by hand and finding the form y equals mx plus b. Well, first, we have to find m. So that's going to be n times the sum of x times y minus the sum of x times the sum of y divided by the quantity n times the sum of x squared minus the sum of x, the quantity squared. Once we have that, then we can find b, which is the second part over here. This is the slope. And if you forget, this is slope. This is our intercept. And it's going to be our y-intercept. And so here we're going to take the sum of y minus m, which we found over here, times the sum of x divided by n. Okay, and so that's going to be how it is. And again, if we think about drawing the graph, say it's a negative slope, here is where it's y-intercept, so that's our b value, and then our slope is basically, the rise over run, or in this case, we're going over one and down so many. So we have to have a negative slope. Okay. Now, if we had to go in the other way, we have a positive slope. And so it'd be something like that. And so that would be up and over. And this is over and down. So it's all a matter of if it's going down into the right or up into the right. So those are the key pieces. Okay. All right. So let's stop there and then we'll come back with an example that'll probably take quite a long time.